Imagine a dinner table. Now, try to imagine that table has to seat 8 billion people.
It is a logistical nightmare.
Right. It's almost impossible to really wrap your head around. I mean, every single day, we as a human race consume this absolute mountain of food.
Millions of tons of grain, vegetables, meat.
Exactly.
Yeah.
And yet, for the most part, the system actually holds. We manage to feed the planet.
We do. And if you zoom out and look at the whole timeline of human history, that is actually the anomaly.
Because we usually struggled, right?
Oh, absolutely. For 99% of our existence, food scarcity was just the default setting. Famine was a regular visitor. The fact that we aren't currently facing mass global starvation is arguably the single greatest achievement of modern science.
It almost feels like a magic trick or some kind of glitch in the matrix. And that is exactly what we're getting into today. Welcome to our deep dive into the Green Revolution.
And we should probably clarify right up front because the name can be pretty misleading.
Yes, good point. When we say green here, we are not talking about recycling or solar panels or electric cars.
Right. In this context, green refers strictly to agriculture. We're talking about a massive, highly coordinated explosion in food production that happened roughly between the 1940s and the 1970s.
Historians often call it the third agricultural revolution.
They do.
So looking at our sources today, we have a huge stack of research. We've got agricultural history reports, economic data, environmental impact studies, and our mission for this deep dive is to unpack how we seemingly hacked nature to save the world from starving.
But we also really need to look at the receipt.
Right, the bill. Because as we are going to find out, this massive success came with a very heavy price tag.
It's essentially a story of trade-offs, really massive, world-altering trade-offs. But before we get into the heavy stuff, I want to stop you right there because there's a huge misconception we have to clear up first.
Okay, lay it on me.
When people hear about science in farming or modifying crops, they immediately think of GMOs.
I mean, I think that is a pretty fair assumption. You hear that and you instantly think of scientists in white coats splicing fish DNA into strawberries back in the 90s.
Exactly, but that is not what the Green Revolution was at all. The Green Revolution actually predates that whole GMO boom of the 90s and 2000s by decades.
So no CRISPR or gene editing.
No gene editing, no inserting foreign DNA into a plant. We are talking entirely about crossbreeding and hybridization.
Okay, so help me understand the difference here. If they weren't editing genes like software code, what were they actually doing back in the 1940s?
They were doing exactly what farmers had done for 10,000 years, just on steroids. They were taking a plant with one really good trait.
Like a thick stem, maybe?
Sure, a thick stem. And they would breed it with a plant that had another good trait, like a really large seed head. But they did it scientifically, highly systematically, and on a massive, massive scale.
So it was about accelerating evolution through careful selection, not engineering it from scratch in a petri dish.
That's it, exactly.
Okay, so it is less Jurassic Park and more like really intense speed dating for wheat.
That is a great way to look at it. And the result of this massive speed dating effort was the creation of what we call high-yield seeds.
High yield meaning they just produce a lot more food.
Right. Specifically for the big three staples of the human diet. So that's wheat, rice, and maize, or corn.
And this brings us to the central figure of the whole story. You really cannot talk about the Green Revolution without talking about Norman Borlaug.
Norman Borlaug, he was an American agronomist who is very often credited with saving more lives than anyone else in human history.
Which is an incredible legacy. He won the Nobel Peace Prize for his work, right?
He did, but the actual specifics of what he did are really interesting from an engineering perspective.
Yeah, I was looking at his time in Mexico and the sources. He was initially down there trying to fight this fungus called stem rust.
Yeah.
But he ended up solving a physics problem instead, which I found fascinating.
Precisely. And this is the key technical insight of the whole revolution. Borlaug realized that if you just make wheat grow better, like if you give it better fertilizer, it just grows taller.
Which sounds good on paper. Taller plant, more food.
Actually, no. If the plant gets too tall and the head of the grain gets too heavy, the stem just snaps. It literally falls over.
Oh, I see.
In agriculture, this is called lodging. And once the wheat lodges, it just rots on the ground. It is completely useless.
So the plant was quite literally too successful for its own good.
Yeah.
It couldn't even support its own weight.
Exactly. So Borlaug did something that seems a bit counterintuitive. He spent years breeding dwarf wheat. He essentially found this Japanese variety of wheat that was short and stubby, and he crossed it with his own high-yield varieties.
So he purposefully made the plant shorter,
Yes. By making the stalk shorter and much thicker, the plant stopped wasting all its energy growing tall. Instead, it directed all that biological energy into the green itself.
Wow.
The result was a plant that could hold a massive amount of food without snapping in the wind.
That is just a brilliant piece of biological engineering. And the numbers from the sources are absolutely staggering.
Yeah.
In regions like India, wheat and rice production literally doubled in the 1960s and 70s.
It was exponential growth. But here is where we have to pause and look at the fine print.
There's always fine print.
Always. Borlaug didn't just invent a magic seed that you could throw in the dust and walk away from.
Right, the sources heavily refer to this as the package deal.
Yes, the package. It was a totally interdependent system. These high-yield dwarf seeds were incredibly high maintenance. Think of them like a high-performance sports car.
Okay, I am tracking.
A traditional seed is kind of like a donkey. It is not very fast, but it can survive on very little. Borlaug seeds were Ferraris. They could go incredibly fast, but they required premium fuel to do it.
And in this farming metaphor, the premium fuel is what exactly?
Synthetic fertilizers, specifically nitrogen, phosphorus, and potassium, the NPK ratio. These new dwarf seeds were incredibly hungry. If you planted them without massive amounts of synthetic fertilizer, they would actually perform worse than the traditional seeds.
That is a crucial detail. So you couldn't just adopt the miracle seed, you had to adopt the entire chemical industry that came with it.
Correct. And they were also incredibly thirsty. Traditional crops were very often rain-fed, but the Green Revolution crops required highly precise water management to actually maximize those yields.
So that means massive irrigation projects.
Exactly. Building dams, carving out canals, and installing massive tube well systems to pump groundwater up to the surface.
And we can't forget the protection aspect of the package either.
Right. Because these new fields were genetically uniform, you had miles and miles of the exact same dwarf wheat. That is basically an all-you-can-eat buffet for pests.
Because there's no natural variety to stop them.
Exactly. If a bug liked that specific type of wheat, it could wipe out a whole state in a matter of days. So the package deal included a very heavy regimen of chemical pesticides and herbicides.
So when we are talking about the Green Revolution, we are not just talking about a change in biology, we are talking about a total industrialization of farming itself.
Yes.
It shifted from this natural biological rhythm to essentially a chemical and mechanical manufacturing process.
That is the perfect summary. It turned the farm into a factory.
Okay, so we understand the mechanics now. Dwarf seeds plus heavy chemicals and water equals massive yields. Now let's talk about the where, because this didn't just happen everywhere on Earth all at once.
No, it followed a specific pattern that geographers call hierarchical diffusion.
Break that down for us, because that definitely sounds like textbook jargon.
It does sound pretty dry. Think of it this way. It didn't spread neighbor to neighbor like a rumor or a virus. It spread from the top down.
Meaning from governments to governments.
Right. It started in the research centers in the U.S., which we'd call the core. Then it jumped to government research centers in Mexico. Then it was handed to national agricultural bodies in India and the Philippines. It was a very high-level transfer of technology between governments and large institutions.
And why those specific places? Why target India and Mexico first?
Simply put, desperation. We have to really remember the context of the mid-20th century. Post-World War II, populations in the developing world were absolutely exploding due to better modern medicine, but food production just wasn't keeping up.
Right.
In the 1960s, India was living what they literally called a ship-to-mouth existence. They were relying heavily on emergency grain shipments from the U.S. just to keep people alive.
Which brings us to the sort of villain, or at least the ultimate pessimist of our story, Thomas Malthus.
The Reverend Malthus. Back in the late 1700s, he famously predicted that population grows geometrically, so that is 2, 4, 8, 16, while food production only grows arithmetically, 1, 2, 3, 4.
Right, so the math just doesn't work out.
Exactly. His conclusion was that humanity is completely destined for inevitable famine because we will always outbreed our ability to feed ourselves.
And for a long time, especially looking at places like India in the 1960s, it really looked like he was going to be right.
It really did. But the Green Revolution was basically a giant take that Malthus moment. By tripling the yield per acre, we broke that arithmetic limit. We figured out how to get significantly more calories out of the exact same square foot of dirt.
And there is a really interesting environmental argument here from the sources that I hadn't even considered before. It is called land sparing.
Yes, and this is probably the strongest argument for the Green Revolution from a purely ecological standpoint. If we hadn't dramatically increased those yields, the only way to feed the growing population would have been to massively expand the sheer amount of farmland.
Meaning destroying nature.
Right. We would have had to chop down the Amazon, clear the forests of Indonesia, and plow the savannas just to plant low-yield traditional wheat.
So by intensifying the farming on the land we already had, we effectively saved millions of acres of wild nature from the plow.
Exactly. And economically, it was an absolute miracle. Global food prices dropped consistently for 50 years. Cheap food is the bedrock of modern civilization.
Because you aren't spending all your money just surviving.
Right. When you aren't spending 80% of your daily income on a loaf of bread, you can send your kids to school, you can buy manufactured goods, you can modernize your entire economy.
So if we stopped the deep dive right now, this is just a massive triumph. Science wins, hunger loses, the forests are saved, and bread is cheap.
If we stop now, yes. But we can't stop now, because you really cannot cheat nature indefinitely. We didn't just solve the problem, we essentially displaced it.
So let's pivot to the bill coming due. We mentioned the package deal earlier. The synthetic nitrogen, the massive water pumps, the chemical sprays. What actually happens when you apply that system year after year for 5 decades?
Let's start with the soil itself. In traditional farming, you rotate your crops. You let the land rest and recover. But the Green Revolution actively encouraged double cropping, or sometimes even triple cropping.
Meaning you just never stop.
Right. You plant wheat, you harvest it, you immediately plant rice, you harvest it, and repeat.
It's like running a marathon every single day without ever sleeping.
That is a great comparison. And to keep that marathon going, you have to dump more and more of that NPK fertilizer onto the land. But soil isn't just an inert sponge. It is a living, breathing ecosystem.
Full of microbes and organic matter.
Exactly. And the heavy, constant use of synthetic salts and chemicals degrades all that organic matter. The physical structure of the soil collapses. It literally becomes addicted to the chemical inputs just to function.
And those chemicals don't just politely stay in the soil, do they?
No, they don't. Plants can only absorb so much nitrogen at a time. The rest just washes away with the rain. It runs straight into the groundwater and the river systems.
Which causes major pollution.
Yes. It causes what we call eutrophication. These are huge toxic algae blooms that suck all the oxygen out of the water, which kills the fish and completely destroys the aquatic ecosystems downstream.
And that is just the fertilizer issue. Then you have to factor in the pesticides.
The pesticide treadmill, it is a classic ecological trap.
Walk us through the treadmill.
You spray a chemical to kill a specific pest, and it works great for maybe 2 years. But then the 1% of those bugs that naturally survive the spray breed with each other. And now you have a resistant superbug.
So the old spray doesn't work anymore.
Exactly. So the next year you need a much stronger chemical, or you need to spray a lot more of the old one. It just escalates.
Our sources actually highlight the region of Punjab in India as a specific example of this trap. Historically, it was the poster child for the Green Revolution's success. It was known as the breadbasket of India.
And today, parts of Punjab are facing a severe health crisis. There are numerous reports of abnormally high cancer rates in those farming communities, which are very often linked to heavy pesticide exposure and highly contaminated groundwater. We effectively traded a calorie crisis for a toxicity crisis.
It really seems like we solved the problem of quantity, but in doing so, we created a massive problem of quality, both for the environment and for actual human health.
That is a very fair assessment. But the fallout wasn't just environmental. It was deeply social. And honestly, this is the part of the story that gets ignored the most, simply because it is harder to see on a neat little graph than tons of wheat produced.
Right. The real-world impact for the actual human beings living in these systems.
Yeah.
I was honestly surprised to read about the gender impact in the sources. I wouldn't have immediately connected new agricultural seeds with gender inequality.
It is a massive ripple effect. In many of these target regions, these traditional farming societies in Asia and Latin America, women played a massive central role in agriculture.
They were the ones out in the fields.
Yes. They did the weeding, the harvesting, and critically, they were in charge of the seed selection for the next year.
But the Green Revolution was fundamentally a mechanized revolution.
Exactly. It brought in heavy tractors, large threshers, and chemical sprayers. And culturally speaking, who was given the training by the government to use these new machines? Who was given the bank loans to buy them?
The men in the community.
Almost exclusively. So overnight, Agriculture went from being a shared family labor practice to a heavily male-dominated profession. Women were actively pushed out of the field and back into the home.
Losing their economic standing in the process.
Yes, and losing their primary decision-making power within the community.
That is a profound cultural shift. And it wasn't just a divide between men and women. It was also a massive divide between big operations and small farmers.
That is just economics 101. The package was very expensive. You needed serious capital up front to buy the fertilizer, the seeds, and the water pumps.
Right.
Wealthy farmers who already had more land could easily get credit from the banks. They bought the expensive inputs, got the massive crop yields, and made an absolute fortune.
And what about the small subsistence farmer? The guy with just 2 acres of land to his name.
He couldn't get the loan, he couldn't afford the premium fertilizer, so his crop yield stayed low. But at the same time, the global market price of grain dropped significantly because the big guys were flooding the market with cheap wheat. He literally couldn't compete.
So the small farmer just goes bankrupt.
Get big or get out. That really became the global mantra. Millions of small family farmers were forced to sell their land to the larger corporate operations and migrate to the cities. It created a massive class divide in rural areas worldwide that still very much exists today.
There is one more major point on the social side that really feels like the big realization for why the food system operates the way it does today. And that is the seeds themselves.
Corporate dependency. This is absolutely crucial to understand.
Walk us through this. Because for thousands of years, as you mentioned, farming was a closed loop. You grow your corn, you save the best kernels from the harvest, and you plant them the next year. Free seeds forever.
Right. That is called open pollinated farming. But Green Revolution seeds are what we call F1 hybrids.
F1 hybrids. What does that actually mean for the farmer working the land?
Well, it means the first generation, the literal seed you buy in the bag from the company, is amazing. It is vigorous, high yield, totally uniform.
Sounds great.
It is. But, and this is the really big but, if you save the seeds from that amazing crop and plant them the next year, the genetics break down.
They don't breed true to the parent plant.
No, not at all. The offspring, which is the F2 generation, are a complete mess. Some plants grow tall, some grow short, some are incredibly weak. The overall yield just absolutely plummets.
Wow.
It is essentially a biological lock. To get that high yield you need to survive, you must go back to the seed company and buy fresh, new F1 seeds every single season.
That completely changes the definition of what farming is. You aren't a self-sufficient producer anymore. You are just a consumer. You are entirely dependent on a corporate supply chain.
And eventually, this biological reality became codified in law with heavy patents. But even without the legal framework, the biology itself forced the dependency. It created a massive captive market for global agribusiness corporations.
So if the price of corporate seeds goes up or the global price of fertilizer spikes, the farmer is completely trapped.
Exactly. And we see this vicious debt cycle playing out today. Farmers borrow massive amounts of money to buy the required inputs, hoping the autumn harvest pays it all off.
But farming is risky.
Very risky. If the monsoon rains fail or the global commodity price of wheat drops, they're left holding all the debt but no income. It is a very, very fragile existence for the people actually feeding us.
So, stepping back, we have this incredibly complex scorecard to look at. On one side, Norman Borlaug and the Green Revolution undoubtedly prevented mass starvation. We are talking about hundreds of millions of human beings who are alive today specifically because of dwarf wheat. That is a triumph that we absolutely cannot dismiss.
It is a profound technological miracle. We cannot understate that fact. It bought humanity precious time.
But on the other side of that scorecard, it turned agriculture into a massive global industrial machine. It created a total dependency on fossil fuel-based fertilizers, heavily degraded our topsoil, polluted our fresh water, and fundamentally stratified rural society.
And that is the exact reality we are living in right now. We are still deeply entrenched in the Green Revolution system. When you go to your local supermarket and see a cheap loaf of bread, you are looking directly at the output of this exact system.
Because it's cheap due to synthetic nitrogen and industrial monoculture. We are totally hooked on it. I mean, we can't just go back to 1940s farming methods tomorrow, or half the world would starve. But we also clearly can't keep destroying the soil and the water forever.
That is the ultimate modern dilemma. We successfully solved the short-term crisis of the 20th century, which was famine, but we very likely might have just kicked the can down the road. We traded an acute, immediate crisis for a slow-moving, chronic one.
So bringing it all together, what does this actually mean for you, the listener? Why does this specific history lesson matter today?
It matters because the Green Revolution isn't just history. It is the active operating system of our modern world. Every single bite of food you take is deeply connected to this massive web of chemistry, genetics, and global economics. The question for humanity is no longer, can we feed the world? We proved we can.
The question now is, how long can we actually keep doing it this way?
Precisely. We beat Malthus in round one, but round two is entirely about sustainability. And if we connect this all to the much bigger picture, it really leaves us with a provocative thought to consider.
What's that?
Well, we culturally celebrated the Green Revolution because it allowed us to essentially conquer nature, to force the land to produce far more than it naturally ever could on its own.
But looking at the severe soil degradation, the toxic runoff, and the looming water crisis.
You really have to ask yourself, did we actually conquer nature, or did we just take out a massive high-interest loan from nature that our children are eventually going to have to pay back?
That is a terrifying but very necessary question to ask.
Mhm.
We solved the famine, but we bought ourselves a massive sustainability crisis in the process.
Because innovation always solves one problem while creating entirely new ones. Our job now is to somehow solve the deeply entrenched problems the Green Revolution created without losing the life-saving gains.
Well, on that note, we are going to wrap up this deep dive. It is complicated, it is messy, but it is the reality of how we all survive on this planet every day.
Absolutely. Understanding the true cost of your lunch is always the first step.
Thanks for listening, and we will catch you on the next one.